In this video, I wanted to take a quick moment and kind of show you one of the things that I really like about Go, and that's its straightforwardness. The way I really like simplicity, and there's a certain kind of simplicity that I aim for. It's where the system does things for you, but it does so in a way that's not tricky. It just does so in a reasonable fashion. So where the interface is straightforward, but also simple. So I want to show you how Go stacks up in just a super simple application with Rails. Okay, because I'm, just so you know, I'm a longtime Rails lover. I've used Rails for over a decade now. I've written most of my apps in Rails, and I've loved Rails. But I kind of think that it's time for Rails to kind of move over a little bit because for a couple of reasons. One of which is that I do think that Go can do a lot of things that Rails does and things Rails can't. But also I think that Rails has kind of bloated itself over the years with too many little ins and outs that kind of detract from the platform as much as they add. So to give you an example, this is just an almost blank application. I'll show you everything that it does. The only thing it does is if you go to ping, I have to run the app. That's important. So if I go into my project, I run the server, and I go to ping, it'll give me back Pong. Okay, super simple app. Okay, but the prerequisites for running any app is this huge tree of files. Okay, if I just say Rails new app, it gives me all these things. In my app directory, I've got an assets folder. Assets folder has folders and folders and files and files. And this is all for just a basic, simple app. And it used to be that you could build a Rails app, and sure, some of this would come along, but now it's just so packed with so many things that it's actually a little overwhelming for doing simple projects. And I think it kind of shoots itself in the foot in many cases. Obviously, you can take some of that stuff out, but then you have to do work to remove things that you don't need. And again, that's work that you don't need. You didn't always have to do it. You come with so many files that the thing is that everything that goes into your repository has to be maintained at some level. So, when you do upgrades, no matter what you do, everything's going to have to be maintained to some extent. And so, anyway, so the fact that it ships you with all this stuff means that all this stuff is you're going to have to carry with you. It's kind of an overhead. So you've got all of these things going on, and especially if you try to, walk a new programmer through it, there's just so much. It's very difficult. So the application itself in my routes file, it's not the right directory. It's in config routes. If you look at the routes, I've got one resource which is ping. If you go to app controllers, pings controller, you can see that that's what it does. It just simply returns a JSON with Pong. So let's see how well this performs. So again, this is just straight out of the box. We'll use Apache Bench. And so we'll just say Apache Bench. We'll do 20 simultaneous connections. We'll do 1,000 of them. And that's at localhost 3000 ping. And so we can see that it takes our time per request is 2.483 milliseconds. Okay, so that's mean across all concurrent requests. And then the actual time per request is about 49 milliseconds. Okay, so depending on how you're counting, if you're just counting the bare throughput, it's 402 requests per second, which is 2.483 milliseconds per request. If you want to look at latency, then it's going to be 49 milliseconds. Okay, so it's actually pretty good, but still this is a pretty basic application, so we'd expect it to be pretty fast. So the problem that I have with Rails is that there's just so much. So like, let's say we wanted to do just a brand new app. We do Rails, new, my app. Okay, so I just want you to look and see how much stuff this thing installs. See, it's got all these files get built, and then it's got all these modules it pulls in. There's just a lot of stuff, and it takes a while to put together. And then if you look at if you try to put this on Docker, the Docker image for this, these things get huge, especially if you have something that builds native modules. Those things just get super big, and it's kind of a pain. So you want to do something simple, and it winds up giving you something complex. Rails used to be one of the system that you went to if you wanted to get a quick app up and running very quickly. And it kind of still is that, but there's it just puts in so many pieces that a lot of the simplicity that was so helpful with earlier Rails is now gone. So now I want to show you how this works in Go. Okay, so for Go, we're going to close these windows. And so with Go, we're going to start out, we're in this directory Go app server, and with Go you always start out building a module. So you have to name the module, and you can name it whatever you want. Usually you name it similar to what the repository you're going to store it in, but you don't have to. We'll call it example.com my test app. And so the executable it will build will be my test app. So we'll do this, and that's going to create this go.mod file. And so you can kind of leave that alone. Go will manage that for you. So now let's say we want to build an app server. So just like with Rails, it's actually Ruby, but you add in the Rails modules. With Go, you start with Go, but you add in the application server. And the one that I like to use is called Gin. Okay, so here's Gin. And so note, this is the location where it lives on the repository. So this is literally the repository for the app. And the way that you would do that, well, actually I'm getting ahead of myself. First we need to start editing the files. So I'll pull up the, so this is the folder. This is my Go app server folder. And that's the mod file that we just made with go mod init. And so now we need to make our main.go file. So main.go, and so Go programs always have a package that they're in, and if it's an executable, it's always the main package. So if you're going to make a library, you could put it in a different package, but your main app goes in the main package. And then you'll always have a main function. So the main function in the main package is what actually gets run. Okay. So we'll save that. But then you import the packages that you want. So to build the app, I've got to import it. We've got to import the module. So I'm going to go to, so the app server I like to use is the Gin app server. And so this is the location where it lives in the repository. So this is all I need. All I need to know is where it lives. I don't need to know a special name for it. I don't need to know anything like that. I just need to know where it lives. So I copy it here, and then I paste it here. Okay, and that tells Go that we want to import that code. And then, so we refer to it by its package name. Now we can give it our own package name if we want to, but usually we just use the package name that comes provided. And usually everyone tries to name their packages according to the last directory that's in the URL. And it doesn't have to be that, but that's usually the way that most people go, just so we're not all confused. So to create an app server, so we create a router, and the router is like the routes file in Rails. And so we just do gen.default. This gets the default router. And this automatically includes a little bit of middleware for exception handling and and logging and a few other niceties. So we do, so that gets the router, and then we can create routes. So we'll create a get route on ping, which calls a function. And this function is going to take a gen context, and now it's going to give a response, give a JSON response. It's going to give a 200 status code, and it's going to give us, gen has a simpler way of giving us a map, which is just gen.h, and we can do message colon pong comma. And so that's what ping runs this function. Okay, and we can store the function somewhere else. We can create an object that has the function attached to it. There's all sorts of things we can do, but this is the simple case. So then what do we want? We want the router to actually run. So do we do r.run? And if you leave it like this, it's fine, but you can also tell it where you want it to run on, which helps in Docker. So we'll run on port on 0.0.0.0, port 8080. That helps in Docker because it specifies IPv4 rather than IPv6. And so that's the whole thing. So now you might say, well, how does it know, like, this is a bare Go installation, so where do you get this module from? Well, the thing is since we imported it literally from the repository URL, the build command knows how to go and get that stuff. So when if I do go build, note that it's going to say go finding module, it'll find the module, it'll download the module, and then it'll download all the dependencies for that module. Okay, so go build did all the magic for us. We don't need to have a place where we say where these modules are stored. We literally, when we do the import statement, that is where the module is stored. And the build system will do all of its magic around that. So it downloads them, it installs them, and there we go. We have my test app ready to run. Okay, so we'll run it. My test app. So now it's going. Okay, and so let's just show it, localhost 8080/ping, and we get back Pong. So how fast does this go? Okay, well, let's run our good old-fashioned Apache bench and find out. I think we did 20 and 1,000 tries. 8080 ping. And so we'll hit this. Do you see how fast that went? Okay, so here we're getting 9,800 requests per second, a time per request of 0.1 millisecond, with a latency of 2 milliseconds. That's ridiculous. Okay, so this is ridiculously fast, and I'll tell you, even when you actually are doing actual things, it's still very fast. I don't want you to get the idea that it's just because we're doing a simple thing that it's fast. I mean, it's obviously not going to be this fast, but it is still ridiculously fast responding when you're doing normal apps. Additionally, it's super simple to Dockerize this stuff. To Dockerize this, you basically have to build a statically compiled app for Linux. Now, I'm on a Mac, if you haven't noticed, but Go is automatically retargetable. If you install Go, everything that Go can target, you can target. So I can just say, so if I do Go OS equals Linux, Go Art equals AMD 64, Go build. So this builds everything, but it builds it for Linux. So I'm going to run my test app, and it's not going to run because it's a Linux app that I'm trying to run on my Mac. So it's not going to let me do that. So now, in order to make this super great for Linux, it's best is if I can have it statically compiled. So I'm going to do go build, and so I'm going to add some linking flags, and let's see if I can remember what they are. And that's going to be link mode static. Nope, that's not it. It's going to be ext ld flags equals dash static. So this will build it so that it's statically built. So that means it requires no external libraries to run. So because it requires no external libraries to run, you can run it in a Docker container that has nothing else, like literally nothing. You don't need a bin folder, you don't need anything. So let me show you what this looks like. So I can create a Docker file. So I'll do a new file, Docker file. So we're going to do this from scratch. It's here. I think you do it with a from scratch. And so scratch is a special Docker image, which means that it's completely blank. So we're starting with nothing. It's an empty image. It's got nothing, no files on it whatsoever. So from scratch, we're going to copy my test app to / my test app. Okay. So then we're going to expose 8080, and then we're going to have the it's called entry point. The entry point is simply going to be to run my test app. All right, so we're literally from nothing, we're copying one file to the root directory, we're exposing the port, and we're running it. Okay, so now we can build our Docker thing from this. Docker build dot, and we'll give it a name, test go image. Let's see here. Docker, I forgot to save it. All right, so now we've built our Docker image. So now all we have to do to run this thing is we can do Docker run, map the port, and then it's test go image. And now it's running. And you can see that it's running. So that is a Docker image that's got one file in it that runs our app, and it runs it super quick. Now it actually is slightly slower because it's running through Docker. So we'll test this out. We'll do Apache bench, 20 connections, 1,000 / localhost 8080 / ping. And so we can see that it was giving us, so we were 0.1 earlier, now it's 0.5. And we're getting 11 millisecond latency. So you can see it's a little slower going through Docker, but nonetheless, it is super fast. We're still going through Docker. We're still much faster than the version with Rails. So anyway, a lot of people after my first video on Go were curious why I thought it was simpler, even though some of the things looked a little weird. And this is why. It's just straightforward. Like, I went from nothing installed, nothing downloaded, and with a couple of lines of code and a couple of commands, it built me an app that was super fast, could be stored in Docker file, and everything's just there and straightforward. And Go handles all the details, but it handles it in a way that's understandable. I have a mod file. This go.mod says that I imported this. Go.sum describes all the things that had to import along with it and what versions it went with. And then this is the actual executable. So anyway, I hope that interests you a little bit in Go and why it's interesting for web application development. And now, one thing about Go is that it's still kind of a young system, and there's still a lot of things that are a little rough around the edges with web development. And I hope to help make some of those a little smoother. I also think that some of the things that are there right now, like for templating systems and stuff like that, are actually a little not very Go-ish. And I hope to help out with that as well. Because if you do it along the Go way, Go actually is a very, very fast system. It's basically writing almost at the lowest level of your computer, and that's why it's so fast. And I try to keep along with that idea as much as I can. So anyway, I hope you enjoyed it. I hope that gives you a little taste of what Go can do for you.